Good day to Dr. Hamida. My name is DT26 from Design Team 26. So I'm going to explain about the project of process safety and operability. First, for Aloha simulations, there are four elements to be considered, which are selecting the location of incident in Kete, Terengganu. Next, date and time of incident, chemical involved, which are methane, and entering the weather's information and ground roundness. Therefore, we can get a simulated picture of thermal radiation check zone as shown. Next, for plant operation system, we need to identify the possible malfunction in the distributed control system. So there are several control loops inside the plant, which are heat exchangers, mixer, and compressor. So therefore, we are used to regulate the parameters such as pressure, temperature, level, and flow. So in the case of major accidents such as explosion of the biomass gasifier R100, the causes can be tracked down due to the failure of the temperature and pressure transmitter. Process hazard analysis is used to provide a management with a solid technical basis in making decisions to reduce the risk and improve the safety of the operations. Therefore, HAZOP is used in the biomass gasification power plant design to identify the possible cause of the explosions and the fire and come up with the effective preventive steps. Let's move on to the HAZOP on the biomass gasifier, in which the table shows the operating summary of the operating conditions, streamline involved, and the operating philosophy. Next, we focus on the study note of the outlet flow, in which we consider about no flow, less flow, and more flow. Furthermore, we also consider the reverse flow in the biomass gasifier. Next, we also study on the reaction pressure inside the vessel, in which there are low pressure and over pressure. Let's say for the over pressure example, the possible causes are regular malfunction and gasifier damage. So therefore, the reactor overpressure may cause explosion and a rupture of reactor. There are some action required, which are installation of high pressure alarm and relief valve. Next, we will move on to the operational temperature in the reactors, which are low temperature and high temperature. So in summary, there are some suitable protection systems based on the possible hazard, which are safety trainings and safety inspection on the instrument, installation of the flow stream control valve, and gas detection system. Next, layer of protection LOPA is used to identify the preventive layer and also mitigation layer in the power plant. In step 1, we are listing out some possible accident scenario and causes associated with the scenario, which are pipe leaking, dust explosions, and operator failure. Next, we also consider about instrumental loops failure. Next, in step 2, we are identifying a single consequences and an accident scenario and causes of the associated with the consequences, which are syngas leaking from the pipeline can lead to flash fire. After we initiating the event for the scenario, then we can estimate the initiating event frequency based on table 11.3. Next, in step 4, we are identifying the protection layer available for the consequences and therefore estimate the probability of failure on demand for each protection layer, which are basic process control system, alarm, and human interventions and safety implemented function. Next, in step 5, we can estimate the mitigated consequences frequency after we combine the initiating event frequency with the PFD. So therefore, the value will give 10 to the power of -7 failure per years. Having the calculated mitigated frequencies, so we can plot the consequences versus the consequences frequency to estimate the risk, which we can see is lesser than once per 10 to the power of 4 per years. Therefore, it's acceptable risk. Next, we should move on to the plant maintenance system, which ensure the optimal functioning and longevity of the industrial plant and equipment, which involve several key elements, which are preventive maintenance, predictive maintenance, and corrective maintenance. Next, we also consider plant startup and shutdown operations procedure. Let's say for the startup procedure, we're having a pre-startup checks, involve inspections, calibration, and safety check, where the initial startup consider radio energizations and monitoring. Next, move on to the stabilization step, which involve fine-tuning and verification. Last but not least, we prepare for the shutdown involving notification and load reductions. Sequential stopping and isolation is essential for the system shutdown. Next, for the post-shutdown activities involve inspections, maintenance, and documentations. Next, we will utilize a case study of Aubrey gasification power plant explosion, which occurred at 7 August of 2017. As an example, to show the improvement on the plant's maintenance system and also improvement on the startup procedures as shown in the diagrams. Next, by using an example of the problem solving and decision making, next we will utilize it to identify and resolve the problems which involve 6 main steps will be shown later. This slide shows an example of the case study which showing the consequences, key components, process, and also type of incident happened in explosion at Oberry EFW plant. Therefore, in step 1, engage, we collect and available information regarding the biomass gasification power plant's explosion at Oberry EFW plants. Next, in step 2, defines, we can find out the safety problem that existed in the power plant explosion, which are power plant emergency system problem, neglected maintenance problem, power plant communication system problem, and mishandling of biomass of EFWs. And of course, step 3, explore. We further gathering the additional information and conduct further investigation to deeper understanding the problems. Next, in step 4, we can identify the root cause of the problem. First, is a leakage at the feed nozzle area of the biomass gasification power plants. Second, system integrity failure, followed by corrosion and erosion of the pipeline. And lastly, inadequate operation diligence and understanding. Next, based on the root cause proposed at step 4, now we can implement the proposed solution to address the identified causes. For the first root cause, we can maintain enough high pressure difference all the times at the feeding equipments or conduct regular inspection and maintenance. For the second root cause, we can enhance the maintenance and inspection procedures and integrate the digital tools and technologies. Next, we can implement a comprehensive operator trainings and multiple communication channels to solve the inadequate operational diligence and understanding problems. And next, we can also upgrade the safety protocols and implement the process stability management. Next, in step 6, look back, we can figure out the preventive steps to avoid the occurrence of the same accident. First, we can strict compliances with the safety regulations, followed by robust training and educations, and last but not least, conducting the risk assessment and management. Moving on to the decision making using Krebner-Trigo method. First is a step 1 problems that we find out the root cause of the explosions. Next, followed up by step 2 requirements. So we need to identify the root cause of the explosion and identify the failure. For step 3 goals, so we can set the goals such as minimize the risk of explosion or ensure the safe handling of the flammable gas. In step 4 alternative, we can come up with several solutions to solve the explosion problem, which are increase the frequency of the safety inspection and maintenance, or upgrade the equipments and technologies. For step 5 criteria, we can minimize the risk of explosions or the operational downtime. Therefore, in step 6, we can decision making tool selections by using the Krebner-Trigo methods. In step 7 alternative, we need to evaluate each alternative using the KT methods with the following weights of each criterion. Therefore, 4 alternatives has been proposed and the total score is shown. Step 8 is validate the solutions. The KT method shows that alternative 4 scored the highest with a total score of 278. Therefore, we can conclude that by implementing stricter safety protocols and emergency response procedure will minimize the risk of explosion, while regular review and update of safety measures should be conducted to maintain a high safety standard. That's all from me. Thank you.